Rémy.
Ooh, that's a lot of you. For most of our history, the sky was our clock. So the sun told us when to wake up, when to plant, when to harvest. It gave us the concept of day and night and seasons, and we imagined 12 months from moon cycles. So time was real and true, and then it started to lie. So let's start with a bit of history. Sir Isaac Newton was born in England on 25 December 1642. But did you know that this person actually had another birth date? Both are correct. The first is in the Julian calendar, invented many centuries ago, and still used in Great Britain at the time, while the second is in the Gregorian calendar, introduced by Pope Gregory XIII in 1582. It fixed a growing gap of around 10 days at the time with nature. So same day, but different dates, and historians have to deal with that constantly. Today we're going to uncover a few traps that we can fall into when dealing with time in our code. I'm Rémy. I'm a senior developer at thoughtbot based in Paris. I love Ruby and I love also astronomy, so I developed a few tools and libs to have fun with time and space. You can find them and anything I do on GitHub and social medias under the handle Hannequin. I'm happy to talk about astronomy and other things after the presentation, of course. And there are a few folks from thoughtbot that you can find as well, including, no pressure, my team lead, director, and CEO. So it feels a bit like a yearly evaluation or termination, I don't know. So I will do my best. So we're going to keep one thing in mind for the whole talk, just a reminder from a user. Remind me at 7 in the morning, wherever I am. So you've probably built something like this at some point, a notification, a recurring email, an alarm. And we're going to watch 6 lies that could break this for us. The first one, we all know a day has 24 hours. Of 60 minutes of 60 seconds. So that's 86,400 seconds. And now let me show you this is actually wrong. So let's pick a time, midnight in Brighton, the morning of a day in October. And then I'm going to add 1 day to it. So we said 1 day is 86,400 seconds. But look closer at the results. This is still Sunday, October 25. Still the same day, we added 24 hours to the date, and we still don't reach Monday. This is weird. So let's use Rails. A lot of us know it. Active support monkey patches the integer class to add method like hours and minutes. So we can write 24.hours, and it reads a little bit nicer than 86,400 seconds. But it does the same thing, because Rails expands the hours method as elapsed seconds. So there is no calendar math involved, and we still don't reach Monday. The reason is that daylight saving time change will happen exactly on October 25 in the UK. So the clocks here go back at 2 a.m., and the hour between 1 and 2 will happen twice. So that day is actually 25 hours long, which is 90,000 seconds. So both 24 hours and 1.day are active support duration objects, but they don't do the same thing. With the hours method, the addition adds a strict duration in seconds, but with the days method, it moves the calendar. That's basically one of the main things to keep in mind for this, because the object that use has different meanings. Semantics will matter. For a reminder, it means that 7 a.m. is 1 day from now and not 86,400 seconds from now. And hopefully this is the last time I say it because it's hard to pronounce numbers for me. let's see a few examples. If we do +1.month, it knows that the month ends on the 28th, so it lands there and not on February 31, which doesn't exist. In the same way, if we do +2.month, it reaches the end of March, even if February and March don't have the same number of days. But if we do +30.days, it just counts days, ignoring month boundaries entirely, because this duration has a different meaning. It's, again, all about semantics. All right, next one, you know time zones. And they do look like geography. You take a globe, you draw 24 vertical lines, you call each strip a zone, and it works. Not really. Before 1840, every town had its own clock related to the sun. So noon was when the sun was the highest point, at its highest point in the sky, as seen from there. But at a given instant, the sun is seen at a different location everywhere on Earth. So when London reads 12 o'clock, Bristol reads 11:50, Brighton reads 11:59, and Norwich reads 12:05. This is called local solar time. And it worked because nobody could move faster than the sun moved in the sky. But then we invented trains. So at the end of a journey from Bristol to London, your clock would be 9 minutes out of sync with the local time in London. It created many problems, including accidents. So in 1847, the British Railway standardized on the Greenwich Mean Time, we call today GMT, and train stations followed a single conventional time, and then entire countries followed that. But then governments started bending those lines. As you can see, China is huge and is wide enough for 5 zones, but uses only one, Beijing time. India is offset with UTC, not with some hours, but also by 30 minutes, and Nepal by 45 minutes. And if you look at Spain, I don't know if you can, but if you look at Spain, it sits at the same meridian as the UK, but it's actually in the Central European time because they moved to that during the Franco era and they never moved it back. So time zones look like geography, but they're just political decisions in the end. And that's one trade we've made. The sun stopped telling us when the time was, because the trains did, and then governments did. And we decided it was worth it because the alternative was unbearable timetables when you move from one city to another. And today, this coordination is way more easier for us when dealing with, talking with anyone around the world. So all these time zones, all the crazy time zone shenanigans are stored in the INAA time zone database. That's more than 600 zones, updated several times a year because somewhere a government decides to do something different. And in Ruby, it's available through the tzinfo gem. So let's use it. But as everything in computing, you know, you need to keep your dependencies up to date. Did you know that Paraguay observed DST until late 2024, and then they abolished it? So with the same code, you can have 2 different answers, depending on whether your gem is recent enough to know the time zone change. And if it's out of date, then you're following time zone rules that no longer apply. And you might need to store the time zones of your users. Not the one that comes from Rails. Rails has also its own way to describe time zones, but it has some more friendly names sometimes, but it's really internal to Rails. It can change. It's not recognized by other systems, so I wouldn't recommend it. So if you need to, it's better to store the INAA name of the zone. And the name itself is not frozen. The INAA keeps the old names working through backwards compatibility links. So the value you stored years ago keeps resolving. And we might need to store it because our reminder fires at 7 a.m. wherever the user is. So we have to know which zone they read 7 a.m. in. local time isn't tied to your coordinates on Earth, it's tied to which administration you are under. Just a small break, I can't keep up. All right, number 3, there is a class we know a lot, time, and 2 methods we reach for constantly. Time.now to get the current time, and time.pass to read a string. From their name, they look very predictable and reasonable. So here my configuration says UTC, but time.now ignores it, because time.now reads the system clock and the system zone, and it doesn't look at your application config. So when you're using the method toDate on them to get the associated date, you get different ones from the same instant. And here as well, with time.pass, in the end, there was no +2 time zone component because it came from my laptop. If I deploy this code to another server with another zone, it will return a different value from the same string. Hopefully we have, again, a nice workaround with active support. I'm sure a lot of you know it. You need to use time.current and time.zone.pass because it will force to use your application config. Either it's UTC or another time zone, but it will use what you declared. And if you're not using Rails, you can also just use time.now.utc, which will default to UTC. At least you know what to expect. Next one. So we talked about daylight saving time already, but there is one more side effect that your code is not going to like. Most countries that observe daylight saving move the clock by 1 hour twice a year. And we already noticed that when the clocks go back, the day is 25 hours long. But let's see what happens when they move forward. So I'm going to ask the UK zone of a time at 1:30 on March 29. But actually, this time never happened in the UK. When the time moved forward, the clock jumps straight over it, so there is no UK instant to return. If you have such a time and zone stored somewhere, you've stored something that never existed, and then your code raises. And 6 months later, it's the same. When the clocks go back, the same world clock time happens twice. So the zone won't pick one for you. It will just ask you which one you meant by raising another exception. That's a bit annoying, so maybe let's not use the tz-info gem. If we use time.zone.pass, the forward case that didn't exist and the back case that happened twice, Rails gives you a default result for both, without raising and without telling you it had to choose. So the two APIs handle this very differently. tz-info will raise when facing issues, and time.zone.pass will just take the same input, pick one, and returns it with no warning. It's quite an edge case, I know. Most apps will never hit it, and you don't need to defend your code against it constantly. But it's real, and it happened twice a year in a lot of countries. For our reminder, we're mostly safe because it's only if the user picks a time right in the gap, like 1:30 in the morning. But again, it can happen even if it's rare. So when you need to handle a user world clock time, I suggest using tz-info directly to avoid silent surprises, and you can still defend against raise. So now we're moving forward. We're getting to know a little bit more of the issues that can happen. And now you deal with it. You did all the work in Ruby. You used time.zone. You handled DST. All your tests pass. But you need to send it somewhere, like a JSON response, or store it in a database column. And that's where you can, again, lose everything. If you look at that, at this point, you might feel safe. It looks good. You didn't forget to use the zone. That's good. The string includes the offset, and the date is nowhere near the tricky ones we've seen on October and March. So it's good. And yes, it's true. Nothing broke, nothing raised. You got a valid JSON string for a valid time. We moved from 9 o'clock to 8 o'clock, but that's just the UTC conversion, so it's cool. But what we actually lost is the offset. The string had +1, and the JSON doesn't. So we lost some of the context. And even this context was not complete, because UTC +1, it can be Brighton in summer, like now, or it can be Lagos. It's just an offset. It's not the full time zone. If the consumer needs the user's civil time, the INANM has to travel separately in its own field. Because once you leave Ruby for serialization or storage, remember the zone won't follow you. If you need it, make sure to include it. Again, it comes down to what you're carrying. If it's an instant, a real moment in time, then UTC is enough, and the zone will be just for display. But if you're carrying an intent, a local time that's meant to stay local, like our alarm at 7 a.m., then the zone is part of the meaning, and you have to keep it. Unfortunately, most of the storage systems won't make it easy for us. The biggest trap is PostgreSQL timestamp TZ. From the name, you can see it carries a zone, but it doesn't. The value gets normalized to UTC on the way in, and it comes back in the session's time zone on the way out. MySQL has datetime, but it ignores time zones entirely, and SQLite doesn't even have a date type. So if the zone matters to your domain, you need to include it and store it with the instant in its own column. All right, we're getting there. This one is a bit special. Until now, our reminder fired at 7 a.m., the number the user gave us. But some reminders don't work that way. What if the user really wants is to be notified at midday? It's easy, midday, it's noon. But actually, the user said midday, when the sun reaches the highest point in the sky. And that's actually almost never 12 o'clock. On February 11 in Brighton, the sun reaches its highest point in the sky at 12:15, but on November 3, it gets there at 11:44. That's half an hour apart, depending only on the day of the year. This is called the equation of time, and it exists because the Earth orbit is not a perfect cycle, and because the axis is tilted. In short, it means that the sun runs a little bit fast for part of the year and a little bit slow for the rest. So clock time is just an average. That's the mean part when we say mean solar time. It lines up close enough with the real sun, but it's a human construction, and it's not really what's happening up there. Because if you photograph the sun at the same clock time every day for a year, you don't get a single dot. You get this, a figure 8 called an analemma. And these dots show the many times the clock and the sun disagreed. The sun is exactly where it should be on each one of them. It's the clock that is averaging, pretending time is regular. I know this is not code, but I think it's good to know that a lot of the weird stuff we have to deal with related to time is just a reflection of nature's chaotic and beautiful side. And just a little bit of shameless self-promotion. If you want to deal with astronomical wonders in Ruby, you can check the Astronoby Ruby gem that I maintain with a lot of love and passion for the Ruby community. All right, back to the reminder. Notify the user at 7 a.m. wherever they are. We spent 6 lives watching that one notification possibly break. Let's try to build it for real. The trap is making the computed time the thing you go back to when you need the answer. If the user moves country, or if there is daylight saving time shift, then the value you stored is wrong, and nothing is telling you it is. It's not wrong to store a time, but it's important to remember the intention. And in our case, the truth is the inputs that produce the answer. The local time the user asks for, which zone they read it in. We compute the next fire time when we actually need it. For recurring reminder or delayed notification, You can store the parameters and compute the result when you need it. If the user's context changes, it means the parameters are updated, and the computed time will stay relevant. It could look like this. So first, you get the zone from the INAA name. Time.now.utc is the current moment. The zone turns it into the local date, and we add 1 calendar day. That's the accurate definition of tomorrow where the user lives. Then you can use the local time method to build the instant the user asks for, 7 a.m. of their time, and that's it. You might want to defend this and be super cautious with handling the DST edge cases we've seen. I didn't put it for readability, but you can put it there, and that's just it. And once you have it, you might want to display it. There are multiple ways. So you have first the UTC offset. It does the job most of the time, but it can be ambiguous. The time zone acronyms are short, easy to read, but AST is both Arabia Standard Time and Atlantic Standard Time. And those are 7 hours apart. So, and the INAA names are absolute, but who actually remembers the zone names? Probably nobody. So if you want absolute precision, you can combine them. The zone tells you which zone it is. The offset lets you do the math. I know it looks a bit overkill, and it probably is, but if your app crosses zone, or if, like me, you like accuracy and precision, then it can be an effective format. So when dealing with time, I really encourage you to ask yourself the right questions first. Name what you have before you pick a method, because the same date-time column can mean an instant, a clock time, or recurring intention, and each one will want a different tool. I came up with this checklist to summarize the key points. If you're an experienced developer, you probably already used most of these because they became best practices over time. So there is no actual conspiracy theory in this presentation related to time, but I just wanted to remind us why caution is necessary when dealing with time. So now you know. A day is not always 24 hours. Dates don't always follow each other, and time zones don't sit still. And weirdly enough, even the sun and the moon don't always rise. If you live in the north of Norway or in Antarctica, there are days without sun at all. And because the moon rising time drifts about 50 minutes every day, there are some local 24-hour windows that don't contain a moonrise. So never trust your instinct about time. We started with the sky as the only one clock, and everything after, the calendars, the 24-hour day, the time zones, time on your phone, we built on top of it so time would be easy to store and to compare. But those are just abstractions that bend the truth. Because time is not complicated, but our world is. And I think it's about time now.